Hi everyone. In this video I'm going to be going over the hands-on labs from Chapter 14. These are out of the CCNA Routing and Switching Study Guide written by Todd Lommel. Chapter 14 is all about IPv6, the different methods of creating and assigning IPv6 addresses for your devices. So there are stateless and stateful methods. So you have some dynamic, some static, some pseudo-static, pseudo-dynamic called Slack, some auto-configuration. Anyways, there's a lot that you can do with IPv6 to get it set up in your network, and what you do kind of depends on the network that you have, your environment. So I'm going to go over some of the basics. I'm probably not going to cover everything in this video, but hopefully we'll get enough to get kind of a basic idea as to how IPv6 really works. So out of the book, we have a topology similar to this. The exact topology in the book looks like this. In Packet Tracer, in order to get this many routers connected to my primary router, router C here, I needed to throw in a couple switches just to enable those connections. Other than that, my interfaces are gigabit rather than just fast Ethernet, but we'll be doing the same IPv6 addressing scheme and everything. So we're going to go ahead and first we're going to start with our primary router, and we want to start by getting it set up to handle IPv6, which we do with the command IPv6 unicast routing. And then we want to go ahead and we're going to statically assign IPv6 addresses to be kind of the gateway addresses. So these two interfaces are going to be statically assigned. And we can just give it the IPv6 address, very similar to an IPv4 command, except the address, of course, is hexadecimal. So there we go, there's 1, and then we want to go ahead and do the same thing with G01, and we'll change the network slightly. Next, we want to go ahead and review it to make sure that it looks correct. One more thing that I need to do in each of my interfaces is give them the noshut command. Should have thought of that. Bring them online so that my router can actually recognize those IP addresses that have been assigned. And then we'll give the command show IPv6 route. And we should see directly connected the network for the two IP addresses that I assigned. We can also give the command show IPv6 interface brief. So here is my command. This shows the two interfaces that currently have IPv6 addresses. So we have a pair of link local addresses, and then my statically assigned IPv6 addresses. So now we want to go into each of our other routers and configure the connected interface to auto-configure. So instead of doing it statically, we'll auto-configure. Because we now have a router on the network, they will be able to detect that router's network and pick up an IP address that'll be automatically configured by the router. So we'll start with router A, and we're going to enable IPv6 first, and then we'll go ahead and set up the interface to handle an IPv6 address, and the command is autoconfig, and then give it a noshut command. Alright, now I want to go ahead and issue the show IPv6 interface brief, just to make sure that it did go ahead and grab an IPv6 address. So I currently have a link local address. So I'm going to come back into my interface and give it that autoconfig command again. see why it's not picking up that IPv6 address. It's online. And so if we compare that to our MAC address, come back up here and find it. So we have our FE80, and then we have the 7th bit, which would fall into here, into this value. The 7th bit in this address becomes 2, and then we have the MAC address D0FF, which is here. And then we inject a little bit of padding, because the MAC address is only 48 bits. Our IPv6 host address needs to be 64 bits for this network. So it injects padding in the form of FF, FE, and then we have the rest of the MAC address, B29801. So all we did was inject some padding right into the dead center, and we flipped the 7th bit. Alright, so we're going to go ahead and do the same thing with routers B, C, and D. Enable IPv6, go into our interface, give it the autoconfig command, and bring it online. Do the same thing in our next router, IPv6, unicast routing, go into our interface, IPv6, address, autoconfig, and bring it online. One more. Alright, in Packet Tracer I'm going to fast forward time just to bring my links up. And then we can go and verify. So let's go ahead and start on D here. So we're still only seeing a link local address. Let's go ahead and create some network traffic. And I am not getting my IPv6 addressing. So we're going to go back into our interface and give it those commands again. Tell it to autoconfig, make sure it understands that it should be doing IPv6 unicast. And there we go, it finally picked up an IPv6 address. Apparently there's a specific order you need to give these commands in, at least in Packet Tracer, kind of being a little bit picky. And if we notice, so we evaluated our link local address, and we see that our IPv6 address on the network matches. So that's how it will do. It'll go ahead and create its own IPv6 address, again, still based off of the MAC address. So let's go ahead and make sure we get everything. Set up with IPv6 addressing. There we go. as an IPv6 address. Alright, so we finally got them to auto-configure correctly. Alright, so the next thing that we would want to do is to create some static and default routes. So we're going to pretend that, for example, A here is off on a specific network, and we want to set up a route to automatically route this direction from its, if there's a LAN over here, for example, or if B had a LAN down here, we'd want it to automatically route. So let's go ahead and get started on that. So here we want to give the IPv6 route and then that network, which was 2001 DB8 3C4D :2:/64. And so this says if anything needs to contact our network over here, then we want it to use interface G00, so it'll be coming out here to reach across the network. And then for router B, we'll actually go ahead and set up a default route rather than a static. And so it'll just be IPv6 route :/0, and again the interface. And so there's a default route. On D and E, we'll go ahead and create static routes again that point to our first network, 1. Like that. We'll do the same thing on router E. Alright, we don't have any routing protocols set up, so we can only connect locally and to directly connected, for the most part, devices. We won't be able to reach across networks yet. Go again to verify that. So next we want to go ahead and set up some routing protocols on C. We could set up some static routes, we could set up default routes, whatever we want to do. But really the best option in most networks is to have some kind of automatic routing protocols, which is where we're going to get into OSPF v3. OSPF v2 handles IPv4. OSPF v3 handles IPv6. So before we can actually configure OSPF, we need to disable and remove any static or default routing that we have set up. So all that work that we just did, we're going to undo it. And that's all it takes, is no, and then the route that you set up, and that will remove that static route. And the default route. Alright, so now we have no routing protocols in place. So we're going to start in alphabetical order across our network, so we'll start with router A. We want to enable OSPF, so we give the command IPv6 router OSPF, and then a process ID number. It's going to be 1 for this. It could not pick a router ID by default, so we want to go ahead and assign router ID. I'll make this 1.1.1.1. Then we go to our interface to actually configure the OSPF protocols there. And I'm just going to go ahead and put everything in a single area. Alright, so it's a lot more simple than OSPF v2, where you have to give your network statements and all that. IPv6 is quite a bit faster. So we'll go ahead and do router B. IPv6 router OSPF1 router ID 2.2.2.2. Then we want to go to our interface, give the command IPv6 OSPF1. Remember, the process ID needs to match. And again, put it into my single area. Go up to C and do the same thing. And then into my interfaces. There we go. And because I have two interfaces here that I want to have OSPF functioning on, so that I've configured both for OSPF with IPv6. We'll come over and do the same thing on router D. And the last one, router E. Go to our interface. Alright, so our routers should all be configured at this point for routing IPv6 traffic. So we want to go ahead and verify that. We'll start with A. And we're just going to use a few show commands. So show IPv6 route. And we should see at least one network showing me OSPF here. And I can actually see two different neighbors. So router A is seeing routers B and C both. We can also give the command show IPv6 route OSPF. I'm not sure if this will work in Packet Tracer. Awesome, it does. So that way I don't have every single route. I'm only showing my OSPF routes. We can give the command show IPv6 interface G00. And that'll be a lot of information. So here's my command here. So all of this is just information relating to that interface that are IPv6 protocols. So IPv6 is enabled. It's got a link local address. It's got a global unicast address, which is that address there that was auto-configured. It knows what network or subnet it is on. It's got multicast addresses, which help to send and receive routing updates. So don't be afraid of seeing those. I believe there may even be some questions on that as far as exams or certifications go, knowing that there are important routing multicast addresses for the routers to send and receive the routing updates. Another command that we can issue is show IPv6 neighbor. So we have router C and the MAC address, as well as what interface on router A we would go through to reach that neighbor. Then we have the auto-configured IPv6 address from router B, and same thing there, and the MAC address for that device, and then their link local addresses, so pretty much the same information there. And you can go through and do that for all of your routers. Once you've viewed your IPv6 configurations, we will want to go ahead and test pinging to make sure that we have traffic across the network being routed properly. In order to do that, you'll need to know the IPv6 addresses. So you can grab it from your commands, and we can get our global address here. I'm going to go ahead and grab a little notepad. I realize you guys won't be able to see all of this, but I'll bring it back over as needed. And I'm just going to create a list for my routers and their IPv6 addresses. Grab D, show IPv6, interface brief. And then we'll grab E as well. Alright, so here's how mine ended up looking. So notice C has 2, one for each network there. Bring that back up. Alright, so now we want to test pinging. So we're going to go ahead and start in A, and we're going to try to ping over to D, for example. And because we're doing IPv6, we need to let it know it's an IPv6 address. And we had a complete failure. So one thing I've noticed when I was doing some of this earlier is Packet Tracer doesn't like IPv6 very much. So we need to check that our routing protocols are in place and functioning. Alright, so after some troubleshooting, it actually seemed that my generic switches weren't handling the IPv6 packets for routing protocols properly. So my OSPF was really messed up. By replacing them with a higher end switch, in this case it was a multi-layer, layer 3 switch, I was able to get my IPv6 routing to work correctly and get my ICMPv6 across the network correctly. So we'll just go ahead and verify this again. I'm going to grab the IPv6 address for router D. Show IPv6 interface brief. We'll grab our address. We'll try to ping across from A. Ping IPv6, paste our address. Alright, so we have success there. We'll do the same thing for E. So here's my IPv6 address. Alright, success. We do the same thing from B. Alright, and there we go. So maybe it's just an issue with Packet Tracer, maybe it was an issue with the specific switches I was trying to use. In any case, you definitely want to verify your IPv6 works. Since this does, OSPF v3 is working correctly now. I'm going to call this a success. Just took a little bit of troubleshooting. As always, if you have any questions or comments, please feel free to leave them for me below. Thank you so much for watching, and I hope to see you in my next video. Bye-bye.